Hello everyone and welcome to the show today. I'm your host Nino, and I am coming to you on this wonderful day, which is the year 2026 Free Day, Free Tuesday. Well, man, time is just flying by, right? And today I'm introducing a trending article from the archives, which is something I am super excited to talk about. The title is Rethinking Momentum Rethinking Optimizer States Through Low-Rank Approximation. The curl is Tabsao Selbis of ORDD 602.24280. It is long. So let us dive right into this massive brain-melting topic. But first I have to ask you something. Why did the matrix break up with the vector? Well, because it just could not handle the cross product. Oh boy, that is an e-slapper. And maybe I am the only one laughing in this room. Anyway, let us get back to the serious stuff. Because this paper is trying to solve a really huge problem in the world of artificial intelligence. You see, when we are training these massive artificial intelligence systems, like the big language models that everyone is talking about these days, we run into a massive wall, and that wall is computer memory. When you train a model with billions of parameters, do not just store the model itself. Oh no, you also have to store the states of the optimizer. The optimizer is the thing that actually helps the model learn from its mistakes. The most popular one is called Adam. Adam is great because it remembers past gradients, which are basically the directions the model needs to step to get smarter. And it keeps track of both the first and second order momentum. But here's the catch. Storing all that momentum history triples the amount of memory you need. If your model is huge, tripling that memory means you need massive server farms. And that costs millions of dollars, which is just not practical for most people. So the problem this paper is tackling is how to compress that memory, so we can train huge models without needing a supercomputer. Well, the researchers had this absolute eureka moment, and they realized something crazy about the math behind the optimizer. They looked at how the momentum is updated, which is usually done using something called exponential moving average. They proved mathematically that this exponential moving average is secretly doing something else. It is actually the exact same thing as training line linear regression using gradient descent. That sounds super complicated. But what it means is that the optimizer is basically fitting a simple linear model to remember the history of gradients. Because they made this mathematical connection, they realized they could treat the optimizer memory just like another machine learning model. And they applied a technique called low-rank factorization to it. Instead of storing one massive giant grid of numbers for momentum, they break it down into two much smaller grids that multiply together. They call this method LoRA Pre. By doing this, they squash the memory requirements down to almost nothing, while keeping the exact same learning power. And they even figured out how to do this for the second-order momentum, which has to stay positive, by using a clever squaring trick. Now you might be wondering how this compares to other technologies out there. Well, there are other methods like the LoRA and Theora that also try to save memory. But those other methods use heavy math operations like singular value decomposition. And they only update their compressed memory every once in a while, because they wait to update. Errors start to build up, and the model gets confused and runs slower. However, LoRA Pre does not have this problem, because it updates continuously every single step, and it seamlessly tracks the changing gradients without building up those nasty errors. The paper shows it completely dominates the baselines, achieving better performance is the only 1/1 of the memory space compared to the others. Oh man, see, what does all this mean for our everyday lives? Well, let me give you 3 really cool examples of how this could be used in the real world. First of all, imagine personalized artificial intelligence assistants running right on the home computer. Usually you need a giant cloud server to train a smart assistant to understand your specific habits. But with LoRA Pre saving so much memory, a regular gaming computer could fine-tune a massive model overnight, or learn your writing style and your daily schedule, all while keeping your personal data safe in your own house. Second, think about mobile phone keyboards that actually understand your weird slang. Right now, your phone has to send data back to big tech companies to improve its predictive text. But with this super efficient optimizer, Your phone could learn and update its own language model locally. Because the memory footprint is so tiny, it would not drain your battery or hide your random access memory, and your private conversations would never leave your device. This could completely revolutionize local medical clinics. Small hospitals often do not have the budget for crazy expensive servers, but they have highly specific patient data that could train amazing diagnostic tools. Using this technology, small clinic could take a genome medical artificial intelligence and train it on their own rare disease cases using a standard desktop workstation. This democratizes the technology, giving local doctors the power of big tech without the massive price tag. So yeah, this paper is not just some boring math trick. It is a key to unlocking artificial intelligence for everyone. By realizing that momentum is just a secret linear nerve, they have paved the way for faster and more private technology across the board. I just find it so fascinating how a simple change in perspective, looking at an old formula in a new way, can lead to such a massive breakthrough. Well, I think I have rambled on long enough for today. Thank you for tuning into my little corner of the internet, and I will catch you all in the next deep dive.